Hi everyone. In this video, we will calculate the limit of the function f in the requested point. So, this is a multivariable limit. Let x equals x, y, z. We know that if x, y, z is on R3 minus 0 and y, c, x it's in R3 minus 0, then the norm of both of them will be the same. This is the norm of x, y, z. It's equal to the norm of y, c, x. And how we know this? Well, because the norm is the square root of the sum of the squares of each element in the vector. In this case, it's x squared plus y squared plus z squared, this in square root. And we know this is equal to y squared plus z squared plus x squared, this in square root, because if we eliminate the square root, then we know that x squared plus y squared plus z squared it's the same as y squared plus z squared plus x squared. So once we know this, and we know this is equal to the norm of x, y, z, and it's equal to the norm of y, c, x, which is equal to the norm of x as we defined it in the beginning, then we can also know that if we do the dot product of x, y, z and y, c, x, this will give us x, y plus y, c plus c, x. But what is that quantity? It's the quantity we have in the numerator. So once we have all of these, we get the absolute value of the function, and this is equal to the absolute value of the numerator, xy plus yz plus cx, over the square root of x squared plus y squared plus z squared. But we know that this is the norm of x. So we have the norm of x here, and we have here, by the definition we see before, that the numerator is equal to the vector x dot the vector x over the norm of x. But Cauchy-Schwarz inequality tells us that x dot y in absolute value it's less or equal than the norm of x dot the norm of y, and this is by Cauchy-Schwarz inequality. And by this, we can tell that the absolute value of the dot product of x with x over the norm of x, it's less or equal than the norm of x dot the norm of x over the norm of x. And if we cancel these terms, we have the norm of x, and by this we know that the absolute value of the function it's less or equal than the norm of x. So we want to prove that this limit is equal to 0. So to prove that if epsilon is greater than 0, it exists delta equal to epsilon, arbitrary, greater than 0. Then if x is an element of R3 minus 0, given that 0 is less than the norm of x less than delta, which is casually equal to epsilon, then the function minus the limit, that in this case we want to prove that it's 0, is less than epsilon. So the proof, we know that f of x it's less or equal than the norm of x, and this we know it because we calculate it here. But we are supposing that the norm of x it's less than delta. So here we have delta, but we know delta is equal to epsilon. So f of x it's less than epsilon, but as f of x it's on R, then in the proof the norm of x, f of x, it's equal to the absolute value of f of x. So as the absolute value of the function is less than epsilon, then the limit as x tends to 0 of f of x, it's equal to 0, because we proved that the function is less than epsilon. And by this we finish calculating our limit. Thank you.